Dear students, let's start the topic of photoelectric effect, which was discovered by Albert Einstein in 1905. About photoelectric effect, we can write that emission of electrons from metal surface by light radiations is called photoelectric effect. Let's discuss about emission of electrons from a metal surface. There's electron emission from metals. About a metal surface, we can say, as there are plenty of free electrons in every metal body. So, to remove free electrons from a metal surface, we need to supply some energy. And this minimum energy we call work function. Like in case of an atom, the minimum energy required to remove an electron from an atom is called ionization energy. Similarly, work function is a specific term which is defined as minimum energy required to eject an electron from a metal surface. That means to a metal surface, when we supply an energy equal to work function, one electron will be ejected out. And if the energy is supplied in form of light radiation, the phenomena of ejection of these electrons we term as photoelectric effect. Like say if this is the situation, this is the metal surface. And we know in metal surface there are plenty of free electrons, and in an isolated metal body free electrons are in randomized Brownian motion. And say if externally some photon is supplied, there is a photon, light photon, which is supplied onto the metal surface, when the photon will incident such that the photon energy h nu is more than the work function. This work function is denoted by the symbol phi. So if the supplied energy to the metal surface for each photon is more than work function, and as soon as photon is absorbed by an electron, this electron will come out, and such electrons are called photoelectrons, which are ejected by the phenomena of photoelectric effect. So this is the way how photoelectric effect is defined. When the incident light radiation has photon energy more than the work function of metal surface, the electron will be ejected out. In detailed study of this photoelectric effect from the next section, we'll study about all the characteristics and fundamental laws related to photoelectric effect. Let's continue on the next sheet about the specific application of photoelectric effect, that is working of a photocell. Let us discuss the working of a photocell. A photocell is a device which transforms electromagnetic radiation energy, or we can call light energy, to electrical energy. This is called a cell because it develops an EMF across its terminal due to the incident radiation onto one electrode of the photocell. Here let's have a look on a specific setup of a photocell. Here you can see this cylindrical glass device is termed as a photocell, which is having two electrodes which are connected here with an electric motor, and a fan is connected to it. Now here you can see when a radiation energy incident on the cylindrical electrode inside the glass cylinder, then you can see if the incident radiation energy h nu is more than the work function of the cylindrical electrode, electrons will start emitting out due to the concept of photoelectric effect. Here these electrons are absorbed by the other electrode, which is in the shape of a rod, and a continuous flow of electrons take place. And here you can see in this circuit electrons are flowing in clockwise manner, and the current flows in an anti-clockwise direction, you can see that emitter will start showing a reading and the fan starts moving. So in this situation, due to the electromagnetic radiation energy, because of photoelectric effect, the electrical energy is produced, and there exists a specified EMF across the terminals of this device, which we term as photocell. So this is the way how, using photoelectric effect, electromagnetic radiation energy or light energy can be transformed into electrical energy.